2a. 200 students estimate the volume V meters cubed of a classroom. The cumulative frequency diagram shows their results. Use the graph to find an estimate of the median. To find an estimate of the median, we need to go to the middle of the cumulative frequency. We have 200 students. This means we want to find the 100th student because the middle of 200 is 200 divided by 2 equals 100. So we go to 100 on the cumulative frequency. It touches the line here, and when we drag this down to the volume axis, we get a volume of 400 meters cubed. This means that the median is equal to 400 meters cubed. Part 2. Find the interquartile range. Interquartile range is 75th percent minus 25%. 25% of 200 is equal to 50. 75% of 200 is equal to 150. This means we want to find the 150th person minus the value from the 50th person. So we go back to our graph, find 150, which should be around here, and 50, which should be around here, and draw some lines. The 100th and 50th person corresponds to 420, and the 50th person corresponds to 350. Therefore, the interquartile range is the difference between the two. So interquartile range is 420 minus 350, which equals 70. Part 3. Find the 60th percentile. So 60% of 200 is equal to 120. So we want to find the 100th and 20th person's value. And we need to go back to the graph for this. 120 on the cumulative frequency is here. And when we draw the line there, the value corresponds to just before 410. So I'm going to say that it's around 409. Therefore, the 60th percentile is 409. Part 4. Find the number of students who estimate that the volume is greater than 300 meters cubed. If we go to 300 on the volume axis, 300 is right here. Right here, it corresponds to 30 people. This means that 30 people estimated that the volume is 300 and less. Therefore, the number of people who estimated that the volume is 300 or greater should be the total minus 30. So that's 200 students minus 30 students, which gives 170 students. The 200 students also estimate the total area A meters squared of the windows in the classroom. The table shows their results. 1. Calculate an estimate of the mean. You must show all your working. Since we have grouped data, we don't know, for example, the first column has 32 students, but we don't know the exact value of each of these 32 students, but we do know that their value is between 20 and 60. So we need to take the middle of 20 and 60, which is 40. The middle of 60 and 100 is 80. The middle of 100 and 150 is 125. The middle of 150 and 250 is 200. So mean equals the total value divided by the total number of students or the total frequency. So to work out the mean, we must do 32 students multiplied by 40 from the first column plus 64 students multiplied by 80 from the second column and 80 multiplied by 125 from the third column plus another 24 students multiplied by 200 from the last column, and this all has to be divided by the total number of students, which is 200. And if you type this into the calculator, the mean is equal to 106 meters squared. Part 2. Complete the histogram to show the information in the table. A histogram has frequency density, not frequency. So we need to calculate the frequency density of each group first. Frequency density is equal to frequency divided by the width of each group. So for the first group, the frequency density is equal to frequency 32 for the first group divided by the width of the group. So the width is from 20 to 60. So the width is equal to 60 minus 20. So the frequency density is equal to 32 divided by 40 for the first group, and that is equal to 0.8. For the second group, we have 64 students from 60 to 100. So the width of the group is equal to 100 minus 60. So that's 64 over 40, and that is equal to 1.6. For the third group, we have 80 students from 100 to 150. So the width is equal to 150 minus 100, so that is 50. And this equals 1.6. And we have to draw this in our histogram. So if we move downwards, the first group starts at 20 all the way to 60. So we're not going to start from 0, 0. The first group has a frequency density of 0.8, so it goes up to here and goes to 60 only. The second group is from 60 to 100, so it will go from 60 to 100 up to 1.6, which is here. And then the third group goes from 100 to 150, and the frequency density is 1.6 as well, so it's going to go like this. Two students are chosen at random from those students that estimated the area of the windows to be more than 100 meters squared. Find the probability that one of the two students estimates the area to be greater than 150 meters squared, and the other student estimates the area to be 150 meters squared or less. So for students that estimated the area of the window to be 100 or more, that means that we're only looking at these two groups right now. We're choosing from these 80 students and 24 students. So we're choosing from 80 plus 24 students, so that's 104 students. So for this to happen, the first student chosen must be greater than 150, and then the second student chosen must estimate it to be less than 150. And then the second scenario would be the first student estimates it to be less than 150, and then the second student estimates it to be greater than 150. For the first situation, the probability of choosing a student that estimates the window to be greater first would be 24, over 104. And then when we're choosing the second student, we now have 103 students left. And out of the 103, there are 80 students that estimated the windows to be 150 and less. That's the first situation. Plus the second situation, where we choose a student that estimates the window to be less than 150 first. So that's 80 students out of 104 students multiplied by, now we have 103 left since we already chose one. And there are 24 students that estimates the window to be bigger than 150. So this is our probability. And if you type this into the calculator, we get 480 over 1,339. And this is our answer. 480 over 1339.